Welcome back to Let's See If I Can Learn Anything by doing Khan Academy, now Intro to Edition.
I'm going to represent with a purple circle, and I'm going to add another one thing. Since this is in blue, I'll make that other circle. I'll make that in blue as well. So let me put that right over here. So 1 plus 1, 1 plus 1. How many total circles do I now have? Well, I now have 2 circles. 1 plus 1 is equal to 2. Okay, you're saying, all right, Sal, that makes sense. Let's do this with larger numbers. So let's say we want to know what equals, and I'll put a question mark over here. So question mark, what equals? So something is equal to, let's say, 2 plus 3. Something is equal to 2 plus 3. What is this something going to be? And I encourage you to pause the video and think about it on your own. Well, you could view this as I have 2 objects, and I'm going to add another 3 objects. How many total objects would I have? So you have your 2 objects, which I'll use purple circles to, again. So so we have 1 and 2 purple circles. This is the 2 right over here. And then to that, we're going to add 3 more circles. And I'll represent those in blue because we wrote the 3 here in blue. So that is 1, 2, and 3. So how many total circles do we now have? Well, we could count them. We have 1, 2, 3, 4, 5. In fact, let me count that. 1, 2, 3, 4, 5 circles. So 2 plus 3, 2 things plus another 3 things are 5 things. So our question mark right over here is equal to 5. So instead of writing the question mark right over here, let me clear that out. I could say 5 is equal to. I could write.
I mean, even though if the result is correct, it could also mean like 10 minus 5, right? On this side, he could write 10 minus 5, which is also 5. It seems like he makes the case that only 2 plus 3 is 5, right? So this is a bit misleading. Let's think, can we find something better here? I would say you should first refer to the equal sign and say that anything that you can find on the right side must be equal to anything you can find on the left side. And the possibilities are of course endless, because 15 minus 10 is 5, 25 minus 20 is 5. So 1 plus 1 plus 5 times 1 is 5. So anything that will equal, which will be equal to the right side, will be equal, right? I don't know, but this is kind of misleading what he's doing there, because it seems like there's only one solution, and that's not right. There are many solutions, many forms of the solutions, and they all relate to each other, right? So he should start with what does the equal sign mean? And usually people would say it's like the scale of justice, like a scale. But I think this is also a misleading picture. So let us think what would be a better picture. To think of an equal sign. Because what does it mean? It means, let us think about an equal sign. This means that things over here are basically the same over here. That means that this is the same as this. So in essence, we only have one thing, right? This does not exist, it's just one thing. And we just give it different colors, maybe. So this means that the yellow circle is equal to the orange circle, because it is the same circle, right? And if we say we take this amount of the circle and then we take the rest, it's the same as if we take half a circle and half a circle, right? It's just, we can just split it up, but it remains the same. And if we take half of it away, like just imagine half, and the 2 halves that are left are also the same. It means if you take equals away from equals, they stay equal, right? How can we, if you add two equal things the equal amount, they will stay equal. If you subtract the equal amount from equal things, they will stay equal. They will be unequal at the moment as you like add something to this side but not to this side, right? Then they will be unequal. So equals will be unequal if you add unequals, right? So there are axioms to be found in here, general principles which this dishy Indian guy is skipping. And even a child can understand this. And he just explained that you and your brother, you have the same money. And if I give you 2 and your brother 1, you will have not the same amount. It will be unequal. So when I would start to explain to a child, I would first explain the concept of equal and unequal, and the child will understand. Equal is when there's no difference, if it's the same thing, and else it will be unequal, and you can play around with it. Do not introduce like 2 plus 3 is 5. This is the wrong way. I feel like you could improve Khan Academy by a lot, or not just Khan Academy, but teaching in general, starting with easy principles. It's like adding things to equals and unequals. I would start there, right? After counting, maybe counting is a principle, but well, I'm not happy with this. Let's go on.
Now that 5 is equal to 2 plus 3.
Banane.
Okay, now we are back. So 1 plus 3 is equal to a lot of things, basically 10 minus 6, because this is 4. Oh, we could not understand your answer. Okay, they just want it in 4. I just want it like this. I'm not really sure what the point of this exercise is. It's just destroying the thinking patterns of a child, right? This is not cool. I mean, this is basically the destruction of, of a young mind flourishing. I mean, I'm an old dude. I'm mentally 80 years old. Okay, my little children, intro to subtraction.
Let's explore what it means to subtract numbers. So let's say that I want to figure out what 4 minus 3 is. 4 minus 3. So one way to think about this is you start with 4 objects. And so let me just draw 4 objects. So there I have 1, 2, 3, and 4. And so this is the 4 objects right over here. When I say minus 3, or if I'm going to subtract 3 from the 4, one way to think about it is I'm going to take 3 of these 4 objects away. So let's do that. So I'm going to take away.
Well, here you could argue that you have an object, right, as he said, and you take something unequal away, right? If you take equal away from an object, it will end up as 0, right? I would explain like this. If you have an object and you take the object away, you will have no object, you will have 0 object. This is how I would start to explain it, right? And if you take an unequal amount away from the object, like not the whole object, what's left? There will be something left, but not the beginning, right?
1, I'm going to take away 2, and I'm going to take away 3. Notice, I took away 1, 2, 3 objects. So how many do I have left over? Well, if I start with 4 and I take away 3, I subtract 3, 4 minus 3, I am left with 1 object right over here. So 4 minus...
Yeah, it makes a lot more sense. Not start with numbers. Start with a general concept. It's always true. If you have an object and you take this object away, you eliminate it. What will be left? 0 object. Every kid will understand this. Give them a kid a piece of chocolate. Take the chocolate away, and he will never forget what it means if you take the same value of the object away. If you take equal away from an object, there will be nothing left. And then next you just tell them, I take any unequal amount left from your chocolate bar, and you will know, okay, so I will have some left, and this is what minus means, right? This is probably a better way.
Minus 3 is equal to 1. Fascinating. Let's do another one of these. Let's figure out what 5 minus 2 is. Let's write it this way. Let's say we want to figure out something, some question mark. Some question. Actually, let me just clear this out. So I'll just do it right over here, actually. So let's say we have some question mark. So there's some unknown number right over here. So let's put a question mark over here. And we say that unknown number is equal to 5 minus 2. So what is this going to be? Well, let's visualize. This means I have 5 things, and I'm going to take away 2 of them. And this is going to be what I have left over after I start with 5 and take away 2. So I have 1, 2, 3, 4, 5 things. And now I am going to take away 2 of them. So I'm going to take away 1 and 2. So I take away 1, 2 objects. So how many do I have left over? Well, I have left over these, let me just in a different color. I have left over these purple things right over here. So how many is that? How many do I have left over? Well, I have left over 1,
This
2,
is
3.
this is also misleading, because it gives you the impression that if you take 2 away from 3, 2 from 5, 3 will be there. Like, this gives the kid the impression it's a mechanical process of the 5 shrinking to 3. But that's not true, and this is not what's happening. Let me show you. This is actually what's happening, right? There's already a 3 over here, right? Which is the question mark, right? This is already, it's existing already. It's not a process of a discovery after you did. He makes it sound like after you did this, then you will get to this, but that's not true. This already exists. A better analogy would be, imagine your little brother has a chocolate bar of, of, of like 3 pieces, right? 1, 2, 3, and you have a chocolate bar of 5 pieces. 1, 2, 1, 2, 3, 4, 5. So they are not equal. What do you have to do to make them equal, right? And the kid will immediately see, oh, I have to take 2 pieces away. So this is when they are equal. 1, 2, 3, or maybe I should have put whatever, 1, 2, 3. So, and then he sees, oh, they are equal, and this is, right? And then next you could say like something like, so now you have an unknown chocolate bar, but I give you the information that it's 3 less of your chocolate bar. So what is this already existing? And it's a point. Okay, where were we? Yeah, back to it. Right, and then we get back to this 3, which already exists, right? So, and he makes it sound like, oh yeah, if you take this away, then you produce the 3. No, it's already there. And this is what kids get the concept that there's a mechanical process involved in mathematics, which is not. You just use this mechanical process to find out what already exists. It's much better to think of the thing you want to find already existing, right? And not like you have to kind of create it, and that's wrong. I feel like that's not the right approach.